Right now, engineers are building a $200 billion monster that will change the map of our planet forever. This is the Nexus project, a massive underwater tunnel stretching 800 kilometers to link Japan and China. It dives so deep into the East China Sea that the water pressure hits 9.4 bars. To build it, workers used the world's largest drills, measuring 17.5 meters wide, to cut through solid rock. This project is a $200 billion bet against the power of the ocean and the crushing weight of the deep blue. But can a tunnel this long really survive in a place where the Earth shakes every single day? The idea of connecting Japan to the mainland isn't new. In 1939, a Japanese engineer named Kuwabara dreamed of a cross-Asian railway. He wanted a train that could travel from Tokyo all the way to the heart of Asia. During the 1940s, people called it the Bullet Train Project. They wanted to move materials and people faster than ever before. But back then, they didn't have the technology to survive the deep ocean. The plan was put on hold for decades. In the 1980s, Japan finally built the Seikon Tunnel. This was a 53-kilometer tunnel that went 240 meters below the sea. It was a victory, but it was also a tragedy. During construction, 4 workers died, and massive floods filled the tunnels with 80 tons of water every minute. Engineers realized that the ocean floor was a dangerous, shifting world of volcanic rock and mud. Despite the danger, the dream of the Nexus project lived on. Countries like China and South Korea began studying the seabed again in the early 2000s. They realized that linking these giant economies could bring in $53 billion every year. They knew it would be the hardest thing humans have ever built, but they were ready to try. But if history showed us it was dangerous, how on earth are engineers planning to keep 800 kilometers of glass and steel from being crushed by the deep blue sea? To start this giant project, engineers had to build the biggest drills ever seen. These are called tunnel boring machines, or TBMs. One of the stars of the project is a machine named the Shanhei. It is 17.5 meters wide and weighs over 5,000 tons. This machine is like a giant, hungry worm that eats through the earth. At the very front, it has a spinning face covered in hundreds of sharp metal teeth. These teeth grind up everything from soft clay to rocks as hard as diamonds. As the machine moves forward, it does something amazing. It doesn't just dig the hole, it builds the tunnel walls at the same time. The machine carries large pieces of concrete and fits them into a perfect circle behind it. This stops the ocean from rushing in and crushing the workers inside. Digging under the ocean is much harder than digging under a city. The biggest problem is the pressure. When you are 78 meters below the waves, the water is pushing down with incredible force. If there is even a tiny crack, the water would shoot inside like a laser. To stop this, the TBM uses a special liquid called slurry. This liquid is pumped to the front of the drill to balance the weight of the ocean. It creates a shield of pressure that keeps the tunnel from collapsing while the machine works. The machine also has a system to wash away mud so the drill doesn't get stuck. If the drill stops moving, the whole project could be ruined. What happens when the ground is too soft for a giant drill to work? In some parts of the ocean, the floor is made of soft mud. A giant drill would just sink or get stuck. For these areas, engineers use a method called the immersed tube. Think of this like building with giant Legos under the water. First, workers build massive concrete boxes on land. These boxes are 200 meters long and can weigh 80,000 tons. They are sealed at both ends so they can float like giant boats. Tugs pull them out into the middle of the ocean to the exact spot where they need to go. Then, the workers let water into special tanks, and the massive tube slowly sinks to the bottom. Once the tube is on the seafloor, robots help line it up with the piece that is already there. But how do you make sure the ocean doesn't leak in through the cracks? Engineers use something called a Gina seal. This is a giant rubber ring that goes around the edge of the tube. When the two tubes are pushed together, the rubber is squeezed tight. Then, they pump out the water trapped between the two pieces. The weight of the ocean outside pushes the tubes together even harder, creating a seal that can last for 100 years. This keeps the inside of the tunnel perfectly dry, even though there are millions of tons of water right above your head. But even if the tunnel stays dry, how do you move millions of people through 800 kilometers without them getting bored or running out of air? The Nexus project isn't just for normal trains. Engineers want to use a technology called vacuum maglev. Normal trains have to fight against the air in front of them, which slows them down. In the Nexus tunnel, the trains will travel inside a tube where all the air has been sucked out. This is like traveling through outer space. Because there is no air, there is no wind to slow the train down. The train also doesn't have wheels. It uses powerful magnets to float above the track. This means there is no friction to heat up the train or wear out the parts. These maglev trains could travel at over 600 kilometers per hour. That is faster than a plane. You could travel across the entire East China Sea in just 40 minutes. Because the passengers are in a vacuum, the train cars have to be built like spaceships. They have to hold their own air and keep the pressure steady so people can breathe comfortably. Inside, designers use special lights and screens to make it feel like you're outside. Even though you are 200 meters under the sea, you might see a fake blue sky on the ceiling. This helps people feel calm, so they don't think about the dark water outside their window. The air for the tunnel itself is also a big challenge. You can't just open a window 400 kilometers away from land. Engineers solved this by building 3 tunnels instead of 1. There are 2 big tunnels for the trains and 1 smaller tunnel in the middle. This middle tunnel is the breathing core. Giant fans on land pump fresh air into this middle tunnel, and it is shared with the train tunnels through small doors. This keeps the air fresh for everyone inside and gives people a safe place to go if there is an emergency. But what happens if the Earth starts to shake in one of the most dangerous earthquake zones in the world? The Nexus project is being built right on the Pacific Ring of Fire. This is a place where giant pieces of the Earth's crust are always rubbing together. An earthquake here can be strong enough to knock down a city. To save the tunnel, engineers had to make it flexible. A normal, stiff tunnel would snap like a pencil during a quake. Instead, the Nexus tunnel is built in segments with joints that can bend and stretch. It is designed to withstand a magnitude 8.0 earthquake. That is a massive amount of shaking. In the most dangerous areas, engineers add an extra layer of protection. They put a 16-meter wide steel liner inside the concrete walls. This steel is strong but can bend without breaking. If the ground shifts, the tunnel will move with it instead of cracking open. There are also thousands of sensors hidden in the walls. These sensors act like a nervous system. They can feel even the tiniest vibration or pressure change. If they detect a problem, they immediately tell the trains to stop and reroute them to safe areas. This technology makes the tunnel one of the safest places to be during a disaster. Building this dream is not cheap. The total cost is estimated at $200 billion. Some experts say it is too expensive and might not make enough money back. They call it an engineering fantasy because the risks are so high. If a major earthquake happened, it could turn the $200 billion project into a giant graveyard under the sea. There are also worries about the environment. Moving that much dirt and concrete can hurt the fish and whales that live in the sea. Despite these worries, China and Japan are moving forward. Some parts of the project are expected to be finished by 2027, and the rest could follow in the 2030s. It is a massive risk, but the reward is a world where oceans no longer separate us. If you want to see more incredible mega projects and learn how the impossible gets built, make sure to like this video, subscribe to our channel, and turn on the notifications so you never miss a story. What do you think? Would you be brave enough to travel 200 meters under the ocean at the speed of a bullet? Let us know in the comments below. See you in the next one.